Hi, everyone. Welcome and thank you for joining us at the Machine Safety Standards and the Changing Compliance Landscape webinar. I'm your host, Carmela Pablo. Before we begin, I just want to go through some housekeeping with you. You will be put on mute as you enter the webinar during the presentation to reduce background noise and disruptions. If you wish to ask a question, please feel free to type your question in the chat box at any time, and we will save those for a Q&A session at the end of the presentation. I'd like to now introduce our guest speakers for today, Jack Whitley and Daniel Nathanson. Jack began working at NHP in 2014 as a sales representative and has advanced his career with NHP into a product manager role. Jack is responsible for the coordination of all marketing, sales, technical, and supply chain of machine safety and sensing products distributed by NHP. Daniel, on the other hand, is the commercial engineer at NHP, where he joined in 2011, specializing in industrial automation, integration, functional safety, and hazardous areas equipment, design, applications, and solutions. He is a current TÜV Rheinland certified functional safety engineer and a participating member of Standards Australia Committee SF041 for safety machinery. Now, without further ado, I'll pass you on to Jack and Daniel.
Thanks very much, Carmela, and hello everyone, and welcome to today's webinar on functional safety standards and the changing compliance landscape. So as you now know, my name is Daniel Nathanson. I'm the Automation and Safety Commercial Engineer here at NHP.
Yeah, thanks, Dan. And I'm Jack Wheatley, and I'm the product manager for our safety and sensing portfolio at NHP. So it's my pleasure to be here with all of you today. Dan and I have collaborated closely for several years now. We both oversee the safety portfolio. So we're both excited to share our experience, our expertise, and insights into this subject.
Indeed, it's great to be presenting with you again, Jack. So these standards that we'll be talking about today are essential in ensuring safety of machinery and how they influence the design, the operation, and maintenance of the equipment. And many of the standards that we're looking at are primarily driven by the European Machine Directive, and they are globally recognized standards and used worldwide, and of course, including here in Australia.
Yeah, that's right. So it's important to note that it is crucial for us to grasp how these standards are applied and how they impact things like the risk assessments and performance levels. So in this webinar today, we're going to explore the variety of the safety standards that are available here in Australia, and we're going to discuss the relevance and how they can be used.
Very good. Let's get started without delay and dive into the realm of functional safety standards and the ever-changing compliance landscape.
Let's do it.
So let's begin by, I suppose, establishing a clear understanding of the concept of safety as it relates to machines. And we're mainly concerned with minimizing any unacceptable risks of physical harm or damage to the health of individuals, which can also result in property or environmental damage.
Yeah, 100%. So when we're addressing safety, our primary focus should be on safeguarding the well-being of people. So it's crucial that we identify and reduce those risks that are considered unacceptable, Dan.
Precisely. So, I mean, it's important to always remember that the safety systems that we implement are primarily aimed at protecting individuals and then secondarily the environment. So while we acknowledge that we also want to protect the machine itself, our main concern is, of course, with the safety of the people using it or people who are located near it.
Yeah, it's a critical point, Dan. So we should never prioritize the value of a machine over the well-being of people's lives. So of course, it's our responsibility to establish and maintain safety measures that shield individuals without making any dangerous compromises.
It's true. Ultimately, the cost of a machine should never overshadow the importance of preserving someone's livelihood, or in some cases, their life. It is our duty, it's everyone's duty to give precedence of safety and safeguard those who interact with the machine.
Yeah, it's a good point. So yeah, I guess as we continue the discussion through the webinar, let's always bear in mind that the safety of individuals is the highest priority. So we're going to explore how to ensure that by implementing an effective safety system and measure that can be achieved.
Cool. So let's have a dig into, I suppose, the concept of functional safety a bit. So functional safety refers to having a dedicated control system, which is in place to oversee and manage the potential hazards that might be present in a machine or its processes. And the main goal of functional safety is to continuously monitor and then regulate those conditions that could pose an inherent risk in any of those machine processes. And if left unchecked, any of these conditions could lead to a dangerous situation.
Yeah, yeah. Look, I guess to add to that, so functional safety systems encompass various aspects. Basic checks like verifying your guard status, to more intricate tasks, such as controlling a robot arm, its speed and position. So I guess these different facets are, they ensure the machine's operated safely. So I guess by implementing, a functional safety system, effectively, we're mitigating the risks to prevent a hazardous situation for people. So this involves integrating monitoring, control mechanisms, so I guess so people are working and with the machine together, and just ensuring that we have a safe operation.
Yeah, so functional safety revolves around using specific control systems which are dedicated to protecting the machine and then the people involved. So it does play a critical role in the overall safety when it comes to machinery and the processes.
Yeah. So I guess moving forward, we're going to explore how those functional safety systems are implemented, and the various components involved, just to ensure that your operation is secure and safe with that machine.
That's very good. So yeah, look, I mean, over the years, you can see that there has been a significant evolution in safety control systems, and that's been driven by various different factors and considerations. And when we look back in time, look back on the history of machinery safety, you can see that there's a significant shift in focus.
Yeah, I really like this picture. So back in the early days, as you can see, productivity, and we all know productivity took precedence over, safety measures being an absolute minimal consideration. So machinery is operated without adequate safeguards that exposed operators and nearby people to numerous hazards. So concepts like hazard analysis and risk assessments were virtually just non-existent. So essentially, it was a bit of a fend for yourself approach. Complete little emphasis on a substantial safeguard or any safety measure for that fact. So of course, unfortunately, this led to higher risk of injuries and accidents. Just fewer safeguards implemented. It was seen as hindering productivity.
Yeah, that's right. I mean, you can almost picture a 19th century workhouse with kids with little arms being able to stick their hands into little tiny crevices of the machine. Not exactly safe practices. But I mean, of course, as time went on, there was a growing awareness among people about the significance of ensuring safety of themselves and their workers. And this does lead to more societal pressures to introduce regulations that emphasize the importance of providing a safe work environment. And yeah, this shift in the mindset raises the importance of safety and brings about more of the concepts of risk assessments and risk reduction strategies. And as a result, safeguarding measures were eventually introduced to prevent individuals from being exposed to hazards, even if it did mean temporarily halting the machine for adjustments or for modifications.
Yeah. So I guess as machinery became more advanced with these intricate control systems, the need for dedicated safety control systems became quite apparent. So these safety systems would typically separated from your standard control system in a typical machine. But it's probably worth mentioning, that the drive to maintain an uninterrupted production, it led to a motivation to bypass or defeat safety control systems. So, people's mindset of prioritizing production at all costs still existed, but despite the growing emphasis on safety.
Yeah, that's actually quite a good point. Productivity and safety have always really been in a delicate balance, and they're often at odds with each other. But efforts have been made to try and strike a balance between maintaining productivity and ensuring a safe and adequately safe work environment for people. And this has become a major focus in the modern workplace now. So you're starting to see more integrated machine safety systems with the control system, and also taking more of a targeted approach with risk reduction. This is, it's actually turned around and improved machine productivity and longevity. You don't need to sacrifice any downtime to ensure safety.
Yeah, 100%. I like that point. The modern approach to machinery safety reflects this new perspective that with the development of standards and the design of a safety system aligning with the goal of optimizing both productivity and personnel safety, we get a much better outcome for all.
That's right. So yeah, when we examine this shift in focus that I'm talking about around machine safety, you can see how it's prompted and influenced the development of safety standards. And then, these standards integrate a lot of what we do with modern machinery these days. But when it comes to tackling the challenge of, devising a safety machine system, we can actually rely on a systematic approach that helps us guide through this entire process. Designing a safety system may seem a bit daunting, but adhering to this safety life cycle ensures that we don't overlook any critical steps along the way. It is an ongoing endeavor to uphold safety throughout the machine's lifespan.
Yeah, no, definitely. So this safety life cycle you can see on screen, it's ongoing, but it has to start somewhere. So it's generally with a risk assessment, and that's where we identify hazards and evaluate the associated risks. So if you look to the second step, we'll then proceed to define what the functional requirements are. So this is also referred as an SFRS. So that's your safety functional requirement spec. So once we have a clear understanding of what the risks and functional requirements are, we can advance to the design and verification phase. So I guess during this phase, we formulate a safety system and conduct thorough verification processes, just to ensure that it aligns with the specified requirements of that machine.
Yeah, and following from the design and verification stage, we can start on the installation and the validation. And this involves, obviously implementing and installing the safety system, but then also validating and testing its performance to make sure it does what it's supposed to do in the actual operating environment, not a bench test.
Yeah, it also doesn't stop there, right? Once the safety system has been installed and validated, we then enter an operational phase. We can't just leave and forget. So, it emphasizes that it's crucial. Whilst the machine is being used and operated, it needs to be well maintained and worked on as needed to uphold that safety system's effectiveness.
Yeah, that's right. As time goes on and modifications are eventually made to the machine, because we all know that does happen. A machine, once it's installed, doesn't stay the same way for very long. So we need to repeat this safety lifecycle process. And this just ensures that, we identify any new risks that may arise as we redevelop the machine during its lifetime and then just address them accordingly.
Yeah, I guess following this structured approach, it ensures that the safety remains a continuous and essential part of the machinery throughout its lifespan. So, it provides a framework for maintaining and improving safety as technology and circumstances changes, as they always do. And I guess what the approach, what this does is it's invaluable for addressing the the challenges of designing and maintaining that effective safety system for any type of modern machine. So I guess it allows us to systematically address the risks and ensure that ongoing safety of our operators and the surrounding environment are continually addressed.
Yeah, the key word there being systematic. So going through the steps, going through the motions, and making sure that everything gets checked off as you go along. Okay, so some safety standards. And luckily, luckily we have got some standards at our disposal, some standards, to help guide us in designing the safety systems. However, it is worth noting that there are several standards that we use in Australia and around the world. And the selection of a particular standard does depend on, things like your familiarity, the design complexity, and the intended deployment of where the machine's going to go. And while personal preference may vary, all three of these standards as of now are still recognized and perfectly valid choices for machine safety applications in Australia.
Yeah, that's right. So in fact, probably still the most commonly used standard in Australia is our AS/NZS 4024.1501. So this is based on the original European standard, which was EN 9541. So that standard, it focuses on the qualitative safety performance. So it classifies the design and the behavior of a safety-related component in a control system and into different categories. However, it is important to note it doesn't consider the fault probabilities or the time intervals between these faults.
Yeah, it has got some limitations, and I love that word qualitative. It's a bit of a mouthful. But on the other hand, we've also got AS 4024 Part 1503, which is a bit of a newer one. It is based on the 2006 version of the international standard, which is the ISO 13849 Part 1. And this standard does take more of this is another great word, takes more of a quantitative approach to safety performance, because it also evaluates factors like things like architecture, the probability of failure, the diagnostic capabilities of the system, and also it's applicable to all types of technology and energy that's used in machines. So, not just electrical components, but also mechanical, pneumatic, hydraulic systems.
Yeah, I did. It's a good point. So yeah, let's look at the third now. So let's talk about AS/NZS 62061. So this standard is aligned with the IEC version of the same number. So like the standard we're just mentioning, Dan, it also assesses your safety performance quantitatively. So mouthful again, but it considers architecture, the probability of failure, and diagnostic capabilities. So it's specifically focusing on electrical, electronic, and programmable electronic technology and those systems.
Yeah, 62061 is a bit of a special case because this one uses SIL, or safety integrity level, which anyone who's ever dealt with process and mining industries has likely seen this one before. That's because it's derived from the same set of standards used in those other industries. It is important to note that all three of these standards, I'll say it again, they're still perfectly valid for machine safety applications in Australia. And just the choice of which standard you choose to use just really depends on the factors like the familiarity, how complex the design is, and just what are the specific requirements of the machine's intended use. Okay. Yep. So I guess another thing to point out, and this is probably the obvious one, is the way in which these standards rank the amount of risk reduction. So they all categorize the integrity of how much risk they reduce in one way or another, but there are some differences. And this illustration, or this table here that we provide, is by no means a direct conversion. Don't use it like that. But it does effectively demonstrate, how the different safety levels and categories stack up against each other.
Yeah, so there are some differences beyond the names. So in Part 1501, we use a range of categories from Category B to Category 4. So B being our least effective in risk reduction versus 4 being our most effective. So, I look at Category B, and it isn't commonly utilized, as it generally involves, using standard components with not much fault tolerance. So they're not specifically designed for safety applications, is the best way to think of it. But they're used with the basic safety principles in mind. And then I look on the other hand for Category 4, and this leverages our higher levels of fault detection and fault tolerance through, redundant components. So this makes it, the most effective in mitigating those risks.
Yeah, Category B, I like to think B is basic. It's nothing. There's no safety equipment. It's just some basic safety principles.
Yeah.
So yeah, in performance levels, on the other hand, that's in Part 1503. So these expand on the concept of safety categories in the older standard. It extends them a bit further to define, not only the architecture, but also, how well does this safety system perform when it's needed. So, it not only examines how the components are arranged, in things like a single channel or dual channel or whatever, but it also looks at the performance and the likelihood that those components will fail. And so this is a more comprehensive approach and provides, I suppose, more of a precise understanding of how much risk reduction is actually achieved by this particular safety control system. So performance levels range from PLA, which is the least effective, that's effectively a Category B, up to PLE, which represents the most effective. And the assessment of performance levels also takes into account, it takes into account the category use of single and dual channel, but also looks at things like the diagnostics and the likelihood of failure.
So let's now look at the last our last graph there, which is your SIL. So AS/NZS 62061. So we encounter safety integrity levels being our SIL. So SIL's it's assigned in ascending order of effectiveness in reducing those risks. So similar to the performance levels, SIL's bound by the probability of failure in a safety control system. So our SIL methodology, it derives from the framework standard IEC 61508. And this caters to the safety of electrical, electronic, and programmable electronic systems. So, in machine safety, SIL 3 is typically the highest level that's going to be required. As anything high is going to pretty much necessitate, a machine redesign. There's, that level of risk associated with something like a SIL 4 is just too high to be able to manage with this standard.
Yeah, SIL 4 is usually reserved for things like, nuclear facilities where there's a lot that can go wrong. You're not going to see that much risk in a machine. So it's generally, if you see there's too much risk and you're looking at a SIL 4 system, you need to redesign the machine. You've got way too many hazards and they're way too risky in there. Yeah. So I mean, look, these distinct levels of risk reduction are assessed and performed, based on specific factors. Like in the case of performance level and SIL, you also need to do calculations. So, when selecting the standard, you just need to make sure that you gather all the necessary information that you need, conduct the appropriate assessments when choosing the most valuable risk reduction strategy, and yeah, go forth and prosper. And yeah, so I mean, if you've ever had to actually look at the safety standards, which I hope some of you have at least at this point, either the international or the local standards, you will notice that there are quite a few to pick from. It's not just necessarily the 3 that we showed in the previous slides. Those 3 that we showed earlier were more around the design of the control system. But that's only one of the steps in the safety life cycle. There are standards written to help us with performing the hazard identification. There's standards for the risk assessment. There's standards for the safeguards and for the different products that we use in them. And there's also standards which are specific to different types of machinery. And these standards are organized in a hierarchy, both at the international level and in the Australian standards.
Yeah, so you can see in the slides how similar they are. But there is a few differences. So in both systems, there are 3 main levels in our triangle. So on the international side, Type A, the standards cover your fundamental concepts and design principles, and that applies to all machinery. So versus Type B, the standards are more generic and can be applied to a wide range of machinery. So, even within Type B, it's been split into B1, and that focuses on, specific safety aspects versus B2, which addresses safeguards. So, I guess if we look lastly at our Type or our C standards down the bottom of the triangle, these have got detailed requirements for specific machines or a group of machines.
Yeah, Australia and New Zealand, on the other hand, we follow the AS/NZS 4024 series of standards, which try to bring a bit more clarity, given the amount of numerous international standards that they have. 4024 just, tries to organize them all into the same series. So, and you can see how it follows a similar hierarchy.
Yeah, so I guess if I look at part 1 in the 4024 series, so this is a mandatory standard that covers safety and design principles. So topics included are around risk assessments, design considerations, device standards. Part 1, it's closely aligned with Type A and B2 standards in the international hierarchy. Is probably a good way to look at it.
Yeah, that's right. They're very closely aligned. And the Part 2 standards include more of the technical topics, which cover things like, the specific safety aspects and strategies that you use in your control system, and the components. And these standards, you would say, are comparable to the Type B1 standards in the international hierarchy.
Yeah. So let's look at Part 3 lastly. So, similar to Type C standards in the international hierarchy. So they focus on machine-specific standards. They provide detailed requirements for particular types of machinery.
Yeah. One thing we should also point out as well is that, the 4024 series itself isn't necessarily mandatory when it comes to workplace health and safety legislation, but it is one of those standard series that could be applied to follow the regulations. And so, if you are following the 4024 series, if that's what you've written down that you're going to do, the Part 1 standards are the mandatory ones. whereas the Part 2 and Part 3 standards are discretionary, and they only really they're only necessary if they apply to your particular machine's design.
Yeah, a good way that I like to look at it to make things easier is, all of Part 1 standards, they're consolidated into a single document, that can be purchased, so that's your AS/NZS 4024 Part 1. So that includes all the relevant standards for machinery safety design, and all the discretionary standards you purchase individually, as required. So
Yeah, that's right. There's no point in buying the standards that you don't need if you don't need them, Whereas the Part 1, well, you do need all of them, so you may as well get them in one hit.
yeah.
So let's have a bit of a closer look at the Part 1 series now. And there are actually quite a few standards in Part 1. It's a pretty thick document, which we are going to cover in a bit of detail over the next few slides. So this slide here has got the first 5 standards, which cover things like a lot of the general principles, risk assessments, and ergonomics.
Yeah. So there are quite a few, as you can see. So these are mandatory standards in AS 4024. So they're worth looking into in a bit of detail. So I'm going to start with 1201. And this draws from the ISO standard 12100, and that serves as the foundation for any machine safety system. So its focus is generally on a risk assessment and then the risk reduction, which provides fundamental principles and terminologies. So this standard does lay the groundwork for identifying hazards, and evaluating the risks, and devising the risk control strategies.
Yeah, it's pretty much the most fundamental standard that you can get. But in Part 1204, this one's based on the IEC version 60204-1. And this one addresses the electrical equipment of the machine. So, AS3000 deals with everything up to the isolator, and then Part 1204 deals with everything from the isolator to the actual machine itself. So this talks about a lot of the general requirements and the recommendations around electrical safety of the equipment. And it also gives guidance around, just ensuring that you've got consistent control schemes, you got consistent operation and feedback, the user friendliness, and just, how easy is the machine to maintain and operate, really.
All right, let's look at Part 1302. So this comes from ISO 14123, Part 1. So it's for considering machines that emit a hazardous substance. So it covers the principles around health risks associated with those substances. So not necessarily used for machinery, which deal with explosive, flammable material, radioactivity. It's substances with extreme temperature and pressures. So these generally fall under their own standards outside of the scope of a 4024, like the AS 60079, which is for explosives and flammable environments.
Yeah, you tend to find a lot of those real hazardous stuff exists in its own separate standard. Where were we? So yeah, Part 1303. This one's based on the ISO technical report, which is 14121.2. It's a mouthful. This one's actually quite a fantastic resource because this one gives you a lot of good practical examples on how to do a risk assessment on a variety of different types of machines.
Yeah, definitely a goldmine of a standard. Particularly if you haven't done in many or any risk assessments before. So Part 1401, it comes from it comes from a European standard. So that's our EN 614 Part 1. And it talks about the ergonomic design principles, how you deal with the interactions between your operator and machinery throughout the entire machine's life cycle. It also encompasses, activities such as your installation, your operation adjustments, your maintenance, cleaning, dismantling, any transportation requirements. So this standard, it ensures that machines are designed with due consideration for all of those human factor, and ergonomic elements.
Yeah, that's right. We still need to remember that people need to operate this machine, so we've got to make sure that it's safe for them to use, not just because of sharp things slicing everywhere, but also it's ergonomic. It's you don't get a lot of muscle and musculoskeletal strains in using it. There is another part that we didn't show on this slide, which is Part 1100. That one is actually the application guide to the Part 1 standards, and that standard is basically all of this presentation lumped into a standard. So it encompasses everything that we're talking about here in the application and the relevance of the Part 1 standards. So let's take a closer look at the part 1, Jack.
Yeah, let's have a look. So let's look at ASNZS 4024 Part 1. And this specifically focuses on designing, safety-related parts for your control system. So they can be often abbreviated as an SRP CS. So
Yeah, SRPCS is a term that's used a lot. We might just call it, safety control systems, probably the easier way to do it, just for brevity. Yeah, this is actually where the real juicy stuff in the 4024 series really starts. My personal opinion, of course. In part 1501, that's one of the ones that we saw in the earlier slides, which was the safety category standard. So, it's based off the EN 954 standard, and which was also the 1999 version of ISO 13849 Part 1. So yeah, I mean, look, this one is a little bit older, but we did keep it in the Part 1 series after being reconfirmed in 2014. That's 9 years ago now. And there is a long transition period that they're sort of accounting for, which allows us to still use categories, because, machine safety is still one of those things that's becoming more and more well understood, and categories is one of those easy to sort of digest concepts. Eventually we will make the transition from categories, by themselves, but, in the meantime, it's still a well-tried method for machine safety design. So it's going to stick around for a little bit longer.
I'm hoping sooner rather than later. So I think we'll be, waiting for a while. But Part 1502, it's another older one based on the 2003 version of ISO 13849. So this addresses the validation for a safety-related parts of a control system. So it provides procedures and conditions for validating safety functions, and then, of course, achieving the desired category. So validation is where we perform analysis, in our testing of our control circuit. And this standard, it offers an example or examples of proven safety principles, and fault exclusions for various components and systems, which people can consider before they put into their design.
Yeah, that one is actually worth having a bit of a read through, because there's a lot of concepts in there for basic safety principles and well-tried safety principles that some people might get a bit confused around. But it does provide those examples, and it's not just electrical. It's also, as I said in one of the early slides, it covers mechanical, pneumatics, hydraulics. So that's another one of the gold mine standards, I guess, 1502.
Yeah.
And then, moving on to Part 1503, you can tell that this one was added on a little bit later because Part 1501 was already used. So this is the performance level standard, which we looked at a bit earlier, and that one takes into account, the probability of failure approach to safety and risk reduction. So currently in the AS4024 series, we're still using the 2006 version of the ISO standard, which was recently reconfirmed. Now, the standards committee, in its opinion, found several flaws, or I suppose points of concern, in the latest international version, which could compromise safety if it was adopted in Australia. There's things in some of the clauses that sort of alludes to being able to use general purpose PLCs for high risk safety applications, which doesn't sit well. There is a new international version which has just been published, and it may be adopted in Australia, but even then, this version still has a few clauses which are a bit of concern. So whether Australia adopts it or not is still yet to be seen. That depends on whether or not we agree to get a modified text adoption, which addresses some of these concerns. So it's still an area of active development.
Yeah. All right. So let's continue into Part 1 series. So Part 1, there are the equivalents to the Type B2 standard. So they specifically cover requirements for safety components and subset systems, specifically focused on interlocks and guarding design.
Yep, this is another one of my personal favorite sections of the standard. Another
There's
important set.
There's a few, Dan.
Yeah, you can tell I've got a bit of a passion for this. Yeah, so these ones are all about the essential components of most machine safety applications. So we're talking about things like the guarding, the monitoring of the guarding, interlocking, and of course emergency stop, because every machine needs an e-stop on it. And starting with Part 1601, this one's based on the European EN 953, and that covers things like the design requirements for fixed and movable guarding, which is used to keep people out and hazards in.
Yeah. So I guess the whole point of guarding is to, minimize the exposure to a mechanical hazard. However, the standard doesn't cover, guards that activate interlocking devices. So this is why we also have Part 1602, based on, it's based on the 2013 edition of ISO 14119. So this one, it concentrates on the interlocking devices associated with those guards. So it gives details to their design and the selection, operating principles, and also the different forms of interlocking devices, that can be used. So the standard, it also addresses the concept of guard locking, so keeping movable guards locked, locked closed during certain parts of a machine process. And it also includes measures to minimize the device defeat. So ISO, it's currently working on a new version in this standard, which Dan's probably across. So,
Yep.
this may also be adopted in the near future, I would expect.
Yeah, the new ISO version of the standard's looking quite promising, actually. So it's going to be a little bit longer than the current one because it incorporates some of the other standards and technical reports that were used with interlocking systems, including things like trapped key interlock switches, which is quite useful because they're also part of this whole guard locking application. Moving on to part 1603, this one is from ISO 14118. And this addresses a lot of the general measures used for preventing unexpected startup, which you use with interlocking, and covers the requirements for things like energy isolation and dissipation, how you do signaling, warnings, and a little bit more related around that.
Yeah. So now, of course, every machine needs an emergency stop function. And this is what part 1604 is all about. So another ISO adoption, and this one comes from ISO 13850, and it focuses on the application of emergency stop functions and their devices. So not just the e-stop mushroom head button, but other methods like pull-wire switches, foot and knee switches, push and bump bars. So it describes how an emergency stop function should work, and accounting for the different zones of a machine, all those groups of machines.
Yeah, if there's one standard I want everyone to read, can you please read this one on emergency stops? Because I've seen a lot that don't follow this type of standard and a little bit subpar. This is another one of those really good ones that give you details like things like, what color the e-stop needs to be, because I've seen black and green e-stops before. That sort of stuff shouldn't fly, but it is covered in this standard.
All right. So last few standards in our part 1 series. So we have those that focus on the human factor aspect of this, of any machine operation and interaction.
Yep, that's right. I did mention that machines are used by people, so they need to be made with people in mind. So part 1701 to 1704. So these provide a bit of a standardized list of human body measurements. And these measurements are essential when you're designing a lot of the safeguarding measures. So things like specifying the gap sizes, access points, just ensuring that machine areas are safe for human interaction.
Yeah. I guess additionally, the parts 1801 and 1803, they outline our safety distances and gaps. So, this standard, it comes into play when we're trying to determine appropriate placement of our guards. So, they're considering factors such as, opening sizes, approaching speeds, and of course, the stopping and performance of a machine. So, it's crucial to ensure that there is enough distance between the human, and the machine to allow for that safe operation to respond in time.
Yeah, these are some of the more important ones to consider when, and we use these a lot when we're positioning a lot of the non-guarding components like light curtains, laser scanners, pressure mats, and there are other standards which we'll get to in a moment which address those. And lastly, we've got parts 1901 through 1907, and these ones focus on the requirements for displays, controls, actuators, signaling. These standards provide a bit more guidance on how users and operators can effectively interact with the machine, in terms of controlling its functions, changing settings, and just receiving feedback on its current state.
Mm-hmm.
Okay, more part 2 standards now, getting into the thick of it.
Love it. Let's dive into what is AS/NZS 4024 Part 2 series. So This focuses on specific safety aspects, and strategies for safety-related parts in a control system. It's important to understand and implement these standards based on, control strategies employed in the machines. So.
Absolutely. So, some of these are more applicable than others. It depends on what kind of control strategies you employ in the machine. So like, for example, part 2501, which is based on ISO 14159, that one looks at things like hygiene requirements. It becomes relevant in situations where there's maybe a hygiene risk to the consumers of the product. And so these are particularly used in machines that are used in pharmaceuticals or in food and beverage.
Yeah, so let's now look at and move over to part 2601. And this covers two hand control devices. So although they're not commonly used nowadays, due to, the available advances in technology with light curtain systems, this particular guide provides, guidance on the design requirements if people do choose to employ that control strategy.
Yeah, we don't see too many new machines coming out with two-hand control these days, but the standard is there in case you do want to implement it. And part 1602 is another good one, which was also recently added into the series. And this one focuses on cableless control systems, wireless. And this standard does become quite valuable for machinery like cranes and gantries, where you typically use things like a pendant control station, and there is a bit of demand to make these things wireless. And it outlines the requirements for the wireless control system itself. The receiver and the transmitter, and it looks at things like communications loss and data corruption. And we get asked a lot about wireless e-stops, and there aren't a lot of very good implementations of wireless e-stops. So that's why this standard has come out to try and address some of those things. What happens if the e-stop goes out of range of the base station? Does the machine shut down, or do we ignore the stop signal altogether?
Yeah.
There's a lot of bad news that comes around wireless stuff with safety. It is possible, but this is the kind of standard that you'd want to look through to make sure that you're doing things properly.
All right, let's look at part 2801. And this extends the concepts covered in parts 1801 and 1803, which were about safety gaps and distances. So this part specifically addresses the positioning of our safeguards. It considers the approach speeds and the machine rundown time. So it proves, particularly useful for machines utilizing non-physical guards, light curtains, scanners, pressure mats, those type of systems.
Yeah, that's right. I mean, anytime you're putting in a light curtain or a scanner, you're going to want to follow part 2801. And then in addition to that, if you're using any other fiddle functions, parts 2802, 2803, 2804, these ones go a little bit further into the presence sensing devices themselves. And these standards, they refer to them as electrosensitive protective equipment, things like safety rated sensors and these kinds of systems. And these also cover a lot of the complementary safety functions like muting and blanking, manual override, and cyclic operation.
All right, let's lastly look at part 2901, which is a recent addition, but it focuses on high voltage machinery. So it outlines the safety requirements for electrical equipment operating at voltages above, 1,000 VAC or 15,000 VDC, and that's up to 36 kV. So, this standard, it parallels part 1204, but specifically addressing those high voltage applications.
Yeah, another new one that got added. So, there was a recognition that there are machines out there that do operate in high voltage situations, and the part 1204 didn't really cover a lot of that. So it was identified that there was a bit of a gap. And so the standards committee thought, all right, well, let's adopt this one in as well. So it can be useful and we can standardize on this kind of stuff. That's what they do.
Cool. Well, let's shift our attention to part 3 series now, Dan. So, this is a whole suite of standards specific to, various types of machinery, right?
Absolutely. And there are currently, at least at the time when we wrote this presentation, there were 25 standards in the part 3 series, and each one of these is tailored to address a very specific hazards or risks or safeguarding requirements that are, these are associated with particular types of machines. Part 3 is actually going through a lot of work at the moment. There's a lot of new standards being adopted into this series, and so we do expect to see a lot more of these in the future.
Yeah. A good thing to note also is that, while you might not see these standards primarily used by, our original equipment manufacturers, our OEMs, who are typically involved in the design, and the construction of machines. They also serve, as a valuable reference for ongoing operation, your maintenance and your safety improvements for any type of existing machine.
Yeah, that's right. So, the Part 3 series covers a wide range of different machine types, as we mentioned. So, things like presses, milling machines, plastic and rubber injection molding, robots, robotic devices, they are coming. Packaging machines like palletizers and wrappers, conveyor systems, forestry machinery like wood chippers, compacting machines like balers.
Yeah, I like it. So I guess I also just thought probably worth noting that the Australian Standards Committee, they're continually evaluating the international standard to identify, additional standards that we can adopt into Part 3 series. So, staying informed about these updates is pretty essential, to ensure the compliance, is met with these latest requirements.
Yeah, and anyone involved in machinery operation, maintenance, or just improvement, you should be referring to the relevant Part 3 standard to ensure compliance and, just to promote a safe working environment, really. So look, staying up to date with these latest additions in the Part 3 series does keep the safety standards aligned with a lot of the advancing technology and innovations that we're starting to see. And the committee's regularly reviewing and implementing these standards to help maintain the safe working environments, in all sorts of different machinery operations. Because, we've identified that it's all well and good to have a lot of these generic standards for machine safety, but sometimes it is actually a lot easier just to follow one of these, which is specific to, it's specific to the injection molding machine that you're using. All the information's right there for you. You don't have to think too hard about it, which is convenient.
All right, so let's now explore, what the latest updates are for AS/NZS 4024 series, and particularly since the 2014 edition. So these updates, they reflect the ongoing efforts of the Australian Committee we mentioned, for machinery safety standards, and how they incorporate these new standards into the 4024 series for AS.
That's 424, yeah. So, currently we're looking at the 2019 version of Part 1, and there have been some significant additions in both Part 2 and in Part 3 since these previous editions.
Yeah, so I'll start with Part 1. So you can see the highlighted standards introduced since the 2014 edition, and that included, application guide, our generic principles and risk assessments, design of control, interlocks and guarding, human body measurements, our safety distances and gaps.
Yep. Part 2's also seen the addition of a few more standards. So we've got that one on hygiene requirements. There's the one on cableless control devices. There's a whole slew of standards on the positioning of safeguards and approach speeds and presence sensing. And then, of course, there's that high voltage one, which we spoke about a bit earlier.
Yeah, so let's now look at the Part 3, and there's some notable updates that have been made to the various machinery types. So presses, plastics and rubber machines, our robots and robotic devices, packaging machines, conveyors are there, forestry machines, and compacting machines.
Yeah, a lot of those are new additions, not necessarily just updates. So Part 3 has exploded in the last few years in terms of the amount of standards that's available there. So look, ultimately really staying informed about the ongoing work of the Australian Standards Committee and Standards Australia, and just in relation to the 4024 series, is quite crucial. It just ensures that we make sure that all of our machine safety practices are in line with the latest international standards as well. And by regularly reviewing and implementing these standards, we can take a more proactive approach in maintaining a safe working environment, because that's ultimately what our goal is.
100%. Sure. Now let's look at our NHP safety services. So, before we conclude, we wanted to highlight some of the safety services provided by NHP that can assist you guys on the call and anyone in our industry with functional safety activities. So our services are part of, Rockwell Automations, authorized as an authorized service provider, being a part of their ASP program.
Yep. One of our key services that we offer is the install base evaluation, or the IBE. And this involves assessing your existing installation. So what's involved is, we thoroughly examine the condition of the components. We address any of the risks that might be associated with things like obsolescence. And then we give you some recommendations for migration or conversions to, just help ensure that there's long-term support for the machine and the components that are used.
Yeah. Additionally, our safety risk assessments, they play a vital role. So, we can conduct conformity audits to ensure the adherence to safety standards and regs. And we can also perform comprehensive hazard and risk assessments. So it provides you guys, with detailed documentation to initiate, the safety requirements specific to a design and process that suits the site.
Yeah, lets us help you generate those correct specifications for the machine. And then, another valuable service that we also offer is in collaboration with Rockwell Automation, and that's the functional safety training. And we do this at various different levels. And so these courses are delivered by a TUV Rhineland certified functional safety expert. That's the title. And this also provides an internationally recognized certification. And they cover things like a lot of the fundamental knowledge, as well as a lot of the advanced engineering concepts. So, equipping you and a lot of the key personnel in your industry with the necessary skills and understanding of the functional safety principles.
Yeah, that's right. I guess ultimately, our aim is to assist everyone, in effectively managing the functional safety requirements and ensuring the compliance with the standards are met. So whether it's evaluating via the install base, going through the risk assessment procedure, or providing a comprehensive training opportunity. For us, it's about supporting our industry, through the entire safety life cycle.
Yeah, that's right. I mean, all of us are roughly in the same boat in terms of our involvement in safety in general for machinery. So even things like the risk assessment, just even starting with the risk assessment, you're already leaps and bounds ahead of what you might have been doing previously. So and any sort of risk assessment that you do is already going to help identify, some of the problems that you might have with the machine and basically take it from there. So it's a really good stepping stone. And that was it from us. So again, thank you very much for everyone attending, and thanks Jack for joining me. Actually, I'm joining you, I guess.
Thank you, Dan. It's been great to chat. I've enjoyed it. I hope you guys have. But maybe let's have a look if we've had any questions throughout the webinar.
Yeah, maybe we'll pass it on to Carmela.
Yep. Thank you, Jack and Daniel, for giving an insightful presentation. To our live audience, if you have any questions, please type it in the chat box. We did get a few questions whilst you guys were presenting. So first question is, are equipment suppliers responsible for validating their compliance to AS4024 with an independent risk assessment by a third party once installation is complete? And what documentation should equipment suppliers be providing to end users?
That's actually a pretty good question. So in terms of the equipment supplier itself validating their compliance, well, let me put it this way. I think everyone involved in the design, installation, the maintenance, the operation of the machine is somewhat involved in AS4024 and just workplace health and safety requirements in general. As a supplier of the equipment, you do want to make sure that the equipment does comply with whatever standard that you're claiming that it does. So I did say earlier in the presentation that 4024 in and of itself is not mandatory, but it is one of those standard series that does help you meet your regulatory requirements. So if you choose to use 4024 to meet those requirements, then yes, as an equipment supplier, you are responsible for ensuring compliance. It doesn't necessarily have to be an independent risk assessment, although in parts 1501 and 1503, which are more about the system design, there are things in there about avoiding systematic failure, and that's things like making sure that your validations and your risk assessments are conducted with third-party people involved, so not necessarily just by one person or one department. And a lot of that comes down to the amount of risk that is associated with that machine. So yeah, you can do your own risk assessments to begin with. And then if you identify that there's a lot that you need to do as part of that life cycle process, you might want to then conduct an independent risk assessment just to make sure that, you've covered everything off. And what was the other one? It was to do with what documentation needs to
Yeah,
be
what
supplied.
documentation should equipment suppliers be providing to end users?
Yeah, so I mean, obviously installation instructions, user instructions, maintenance instructions. If you've implemented a safety control system, you also want to have that that safety functional spec included as well, and that details all of the safety functions, all of the components that are involved, and what performance level or category or SIL do those safety functions need to meet. So this just ensures that if someone does go along and starts messing around with the machine later on down the track, they have actually got some clear details on, you know, what should they be touching, what shouldn't they be touching, and what was the original risk assessment all about. So it's basically include as much information as you can to help help with that machine over its lifetime. That was a good question.
Excellent.
Nicely.
Yep. Jack?
No, all good. I was going to say nicely answered and articulated, Dan.
Thank you. I don't think you could add anything else to that. I mean, if you can, you can. Yeah.
No, let's see if we got any more.
Yes, we got another question. So what if a machine doesn't fall into a category in any of these standards?
Yeah, I'll answer this one again, Jack, if you don't mind.
Yeah,
Um,
go.
Yeah, so there are a lot of different machines that are covered in the Part 3 standards. I think you'll find, you know, you'll find something in there that you should be covered off with. But if your machine doesn't fall into any of those Part 3 standards, then you have to use the Part 1 standards. And they are generic enough that you can apply them to pretty much anything. That's sort of pros and cons. You know, it's good that you can apply it to everything, but at the same time, because it is so generic, there are elements that you might trip over. So it's good to have a look at those Part 3 standards first and just see if there's anything at least somewhat similar, but you always will need to fall back to those Part 1 standards.
Awesome.
Hope that answers the question.
Yep. Excellent. And then last question before we end the webinar. Who can conduct a safety risk assessment? I know you guys have mentioned this earlier, but
Yeah, you can
Great
take that one, Jack.
question. Yeah, great question. Who is competent in delivering a risk assessment? There is no set of black and white standards on who is competent and capable of delivering that. So, yeah, I think you don't need an electrical license, you don't need an engineering degree, but someone who has done the training, has the experience, and you know, I guess is aware of the procedure and the process that you would go through in that safety life cycle to be able to ask and involve all relevant parties to collect all the information. So we're talking, you know, there's maintenance, there's operation, you know, and then there's downtime. So what does that all look like? It's just about understanding that process. So although there's not a black and white answer to who can conduct it, I think it's more about you know, who's actually got a good understanding of that process in the safety life cycle and educated themselves, you know, with the standards to have that understanding. Anything you want to add, Dan?
Yeah, I mean, you've covered pretty much everything, but I might just reword a bit of that.
Go.
So, you know, the question is who can conduct a risk assessment, and I sort of look at that as who's orchestrating it, and that would be someone who's familiar with the risk assessment process. As far as who's involved in a risk assessment, everyone, as many people as you can, because you're going to have varied opinions from different people, and you need to collate that. You're going to have people who have had different experiences with the particular type of machine. You'll have people who have you know, different priorities when it comes to the machine. You know, you will have people who say, no, production over everything. This hazard is nothing. There's no risk. Meanwhile, the operator dude is like, hey, I've got a cousin who lost a finger on this machine. I think the risk is pretty valid. So yeah, who can conduct it? Someone who I suppose is familiar with the process. Who's involved? Everyone.
Yep, I like it.
excellent. Thank you. So that concludes our webinar. Thank you, Daniel and Jack, for taking the time to speak to our members today. And thank you to all who joined us live. Recordings will be distributed shortly after this webinar. If you want to rewatch or share this with your team, and a calendar of upcoming webinars and events can be found on our website. So please register even if you can't attend, as you will receive a copy of the webinar. Once again, thank you everyone who joined us live, and enjoy the rest of your week.
Thanks for having us.
Thanks, Carmela. Thank you, everyone.
Thank you.